Here, let me introduce HyperOracle, which is a programmable zkOracle network. Our start point is the observation that for many depths, it's not as decentralized as we may expect. There are many layers for every depth, right? For example, apart from the first layer, which is often known as the blockchain consensus layer, there are also front layer and there are back ends like your data fetching, your data processing, and your data providing. And each of the layers is hard to really implement in a fully decentralized manner. And the worst thing is the fact that the degree of a decentralization of any depth is based on the most vulnerable, or say the most centralized part of all these layers. The truth is there's a lot happening in the middle layers, though the first layer, or say the layer 1, is secure and the layer 1 is decentralized. For example, your data is provided maybe by a client, maybe by a graph node, maybe by the front end of your browser. That might be centralized and the data might be falsified. And also your client, your wallet delegated service nodes, they may do something to harm your property. And there are solutions to solve this issue. For example, staking and slashing. However, these two solutions have their own problems. For example, for slashing, you have to be a rational node to have the slashing working for you, right? If you are, you just want to break something, you just want to show your courage, or you just want to let people taught a lesson, you are not rational and you will not have the slashing working on you. Also, staking brings in more centralization. We want to solve the centralization problem. However, you bring in more centralization, it's very bad and it's a getting worse phenomenon. Our purpose is to unlock the access to real-time on-chain data without slashing, without staking, only with zero-knowledge proofs. We achieve decentralization for real-time data access. There has to be some data provider if you are a light client. However, we want them to be decentralized, which means that firstly, the data is accompanied by a proof. Secondly, when you there should be more nodes allowed to be data providers if the set is not fixed and it's a permissionless environment. In this way, we can achieve the trustful data in a trustless environment. For verifiers, they fetch the data and they get the proof for the data. And we want to build a network of zkOracle, which allows nodes to process or say process some data and give you an output along with a proof for it. You get the proof and you get the data. You can do the verification yourself in the local and or by the smart contracts. To build the zkOracle we just mentioned, we will use zkgraph, which allows you to define your own data mapping and which is the fundamental building block of many applications like zk indexing and zk automation. zkgraph allows you to design your customized data logic in an off-chain environment. It guarantees the integrity of computation from any node and can verify results either on-chain or off-chain. By on-chain, it means you can deploy a smart contract which is designed by us, which is automatically generated by our server, which is very hard to write yourself. And you can get your proof verified on-chain by the smart contract. And also you can verify it locally because it's very efficient to verify. And since our time is quite limited, we will proceed by a demo. And the demo is a recorded video since we cannot do it on site. Yeah. Okay, let's record the definition of zk graph. It consists of the data logic that is customized. You can write your own logic. It seems to be very long, but most of them are templates. You do not need to understand every line of them. And you can design your, after that, it's compiled into awesome code as shown here. And you can design your interested event in the on the right, we just have omitted. After that, you can set up, get the awesome code. It can be downloaded, of course. You can set up and get a zk awesome image. And zk awesome is the one zk VM which is designed by us. And if you are interested in that, you can contact us for more detailed information. It may take some time, so we can make it quicker. For the moment, the proof involves the network issues, so it's not very fast as we expected. And then we can execute it and get the execution result. In the next, we can generate our proof, which also takes some time, and we can skip some parts. And and here you can see the proof transcription and all the data you desired. Then you can do the verification. Before that, we are only showing the online version, which means you can deploy your smart contract. And the deployment takes some time. Finally, you can verify it and it's valid. Okay. And we can stop the video now. Okay. Okay, I think it's all. There is another PPT slide which is maybe not in this version. And thank you.